Okay, so this is our last question. And it says Starbucks Grande cups hold 16 ounces, and the venti cup holds 24 ounces. So that's volume. So if we compare those, what we first recognize is that's a K cubed value that we're going to solve for. The question is, assuming the two cups are similar shapes, how much more material is required to make a venti cup compared to a Grande cup? So if we actually draw a Starbucks cup, here's a Starbucks cup. So it's basically saying how much material is actually needed. So if we actually like unwound it, the actual material shape is going to be, has a circle on the bottom, and that's a cone on, it's kind of like a cone on the outside to make that. So if you actually were to roll, this is our circumference right here, circumference, that's going to be the same as this length right here. So if we were to roll this shape around it, we would eventually create this cup shape. So what costs money for a production person is, they say literally how much physical material is required to make this cup. That's what we're trying to find out. How much more does it cost? And then you can actually do a cost benefit analysis of like what are they actually like, well, comparing how much it costs to make, like is it more beneficial to sell small cups or big cups, etc. Okay, so first of all, I was saying any area, but it doesn't actually give us any dimensions of the Starbucks cup. So for this one, we really need to understand how k squared, and k cubed works. So give us volume first. We can solve for k cubed. We say, okay, k cubed is just compare volumes. So if we're going from 24 ounces from 16 ounces, you can see what the value is. So 24 divided by 16, and that is 1.5. So that's what k cubed is, 1.5. But it's asking us how much more material is required to make a venti cup. So it's what it's asking. Material is area. This is area. Right? So we need to find area. So basically, we need to get to k squared somehow. So what we're going to do is we're first going to cube root this value. If we cube root this value, actually let's start with a different line actually. If we cube root this value, so we have k cubed is equal to 1.5. If we cube root this, the cubes are going to cancel on that side, so k is equal to. So cube rooting is the same as, if you don't know where your cube root is in your equation, cube rooting is the same as saying to the power of a third. Okay, so 1.5 to the power of 1/3. And we get 1.1447. And the number keeps going. You can always confirm if you go back. It's just to make sure you did it right. You can then cube that number again. Yeah, it still equals to 1.5. So now if we want to find the area increase, we're just going to square that number now. So we have k is equal to 1.1447, and we're going to square that. If we square it, we know this gives us the comparison between areas. So this number, we're going to square it. We get 1.3. 1.31. That is our area scale factor. So we can actually think of this as like, okay, for the difference between Grande cup and a venti cup. For a venti cup, it needs to be about this amount taller. So basically, if the original thing was like 1 unit tall, the next cup, if it's similar objects, would be 1.145 units tall. This one can hold 1 unit of area. The new one can hold 1.31. Sorry, 1.5. But you get the idea. So basically, it's going to be 1.1447 times taller. It's going to require 1.31 times more area, but it can hold 1.5 times more stuff inside the cup.